Mount Pinatubo, we know it as a mountain, we don't know it as a volcano.
It was supposed to be a sleepy, harmless mountain.
And the worst is yet to come in the Philippines. Mount Pinatubo on the verge of blowing apart.
It was one of the worst volcanic eruptions in history. Followed live by the entire world. From the first tremors to the final explosion.
The magma reservoir is between 40 and 90 cubic kilometers of material.
And at Pinatubo, the eruption potentially kill everything from 10 to 20 kilometers out.
Let's drop down a bit. Okay, coming down, standard, using throttles.
It's a little bit larger than ash is what's falling right now from Mount Pinatubo.
Over 500 people were threatened by the volcano.
What if it accelerates quickly?
And we saw a huge cloud.
That could create a real volcanic winter.
And he said, this is the end of the world. Repent, repent.
If someone had told me I was going to attend one of the biggest eruptions in the past 100 years, and at the same exact moment there would be a typhoon, I would say no. That's a stupid Hollywood scenario.
An eruption signal will just go. That is one of the most terrifying things you can hear.
June 15, 1991, the Philippines, Southeast Asia. One of the most dangerous volcanoes in the world is about to erupt. A team of journalists is sent to the site to look for the slightest sign of eruption.
Scientists from Philippine volcanology said that there's an imminent eruption, but there was no date.
And then suddenly I felt like tremors. I said, did you feel that? I told the driver. He said, yes, the earth is moving, Chari. I heard frantic screams by my colleagues. My cameraman was saying, it is exploding!
This eruption will go down in volcanic history and will impact the entire world. The energy burst is equivalent to 350 nuclear bombs.
Look up at the right side. And we saw a huge cloud going down, rolling.
And I said to the driver, faster, faster, it's getting bigger.
The footage filmed from the fleeing journalist's car shows the phenomenon's brutality. Here, what appears to be the horizon is actually an ash cloud advancing at more than 60 miles per hour.
You can hear the rumbling. If you imagine 100, 200 horses, that's the sound. And then you can see the stones lighting and sparking. That was it. And I said, that's my death.
Despite their fear, the photographers capture the moment. An extraordinary moment, frozen on film.
In my mind, I'm going to die. That was it. because it's very fast. How can you overcome that? You can't.
The Pinatubo eruption raises great fears. The impact of its smoke cloud will be global. A situation that no one, not even volcanologists, could have conceived 3 months ago. Tuesday, April 2nd, 1991. Summer vacation starts in the Philippines. From Manila, the capital, buses are filling up. Planes are taking off. The destination, the rice terraces, plateaus, and turquoise water lagoons. While it seems that most of the population is on vacation, this is not the case for the expert group of PHIVOLCS, the Philippine Institute of Volcanology and Seismology. They're heading towards a phenomenon that has just occurred.
My name is Maria Leonila P. Bautista. I am a geologist at PHIVOLCS. I actually graduated in 1984, and PHIVOLCS is my first job. At that time, I used to work with the geology group and the volcano monitoring group.
The scientist is well aware of the geographical singularity of the Philippines. The archipelago is in fact located on what volcanologists call the Pacific Ring of Fire, an array of active volcanoes that extends from New Zealand to Chile.
The Philippines is located on a subduction zone because of the Eurasian plate, which is subduing. So who is going to sink under the Philippine plate? We have one plate that'll go under another, and a zone filled with magma. And the magma that's created here will rise, be stored in the crust, and then basically create a volcano.
In the Philippines, I think there are about 50 volcanoes that are more or less active. There are volcanoes that are almost permanently active, like Mayon, or the Taal.
These two volcanoes are considered explosive. Their eruption creates a cloud of ashes capable of destroying everything in their environment. It's different from effusive volcanoes with slow lava flow, like here in 2016 in Réunion, near the crater of Piton de la Fournaise. The vast majority of active volcanoes are known to scientists. However, this mountainous landscape might surprise them. Its name, Mount Pinatubo.
The people who alerted us that there was explosion were the nuns or the sisters, the religious group who was doing catechism work in the region for the ATAS of Pinatubo. So they said, the natives and us, we saw the explosion, and there were 4 explosion pits, and we are concerned that it's going to worsen.
This information is very worrying, because scientists know almost nothing about Mount Pinatubo.
We didn't have equipment in that volcano, so it was unmonitored.
Mount Pinatubo is new. We don't know this Pinatubo, and we don't know if it's a volcano. We know it as a mountain. We don't know it as a volcano.
Pinatubo had a fairly rounded peak, entirely covered by forests. This is why when you look at the landscape, you wouldn't necessarily suspect that there was a volcano there. There was even a study in 1909 that concluded that Pinatubo was not a volcano according to observations.
What do these explosions observed by the nuns hide? Mount Pinatubo will soon reveal its true nature. "24 hours later, PHIVOLCS scientists arrive at the location. The images taken from their helicopter show the start of a volcanic explosion for large fumaroles rising up from the mountain. And that's not all.
So right away, the next day, we decided we have to put equipment. They put those seismographs, and right away, they detected hundreds of earthquakes.
They installed 5 seismometers around the volcano and recorded up to 500 tremors per day. But the question was, since there was no prior surveillance, how would you know if these tremors correspond with the normal behavior of the volcano? Or is it a sign of a reactivation of the entire system that potentially represents a risk of eruption?
This actually demonstrates the first sign of an explosive eruption. Scientists call it a phreatic eruption. "6 miles underground, 2 types of molten rock are about to mix. On the one hand, dacitic magma, gas-charged and thick. On the other hand, basaltic magma, which is particularly liquid and hot. Their union creates a gigantic explosive cocktail. It moves through the rock crust and heats the groundwater."
A phreatic eruption is when a pocket of groundwater explodes due to underlying magma heating the chamber. So the water in the chamber turns into steam like in a volcanic pressure cooker.
Faced with the dangers that lie ahead, Philippine scientists are appealing to their international counterparts.
Philippine volcanology, seismology, they don't have enough equipment to read how big an eruption it will be. So they called the USGS.
USGS is the United States Institute of Geological Studies. In fact, it is responsible for seismic and volcanic monitoring on American territory, but they also have a support service for other countries.
Our mandate was to keep a team that was ready to respond to volcano crises, but also have equipment on the shelf that we could take somewhere to respond to a crisis. And so we gathered the equipment that we had, and we went to the Philippines to help FEVOLCs.
Andy Lockhart and his American colleagues cannot yet imagine that they are going to witness the largest volcanic eruption in 100 years. Tuesday, April 23, 1991. 3 weeks after its first signals, the mysterious Mount Pinatubo will reveal all its secrets. 20 kilometers from the volcano, on an American base, all the scientists are gathered for a large-scale operation.
Where the light and the power were, that was where we had reliable telephone connections. We had the cooperation of the U.S. military in taking care of logistical issues. Most importantly, they had a couple of helicopters. We were going to need helicopters to get out and place these monitoring stations around Pinatubo.
I'll tell you what I could probably do.
In this battle with the volcano, the soldiers are spectators. The scientists are running the investigation. There is work to be done. Before alerting the population, volcanologists need to know the past of Mount Pinatubo, the dates, and the extent of its ancient eruptions.
The scientists had a real police investigation on their hands, so they sampled carbonized charcoal and carbon dated it back to the 14th century, and they were able to reconstruct an eruptive story.
We determined that there had been eruptions 600 years before present, and then I think about 3,000, another one about 5,000, and so forth. There have been a number of these eruptions. It was fairly frequently, in terms of geologic time, it was erupting every few hundred to every few thousand years.
In this year, 1991, Mount Pinatubo is indeed in a revival cycle, and it is therefore dangerous. The answer will soon be given with the establishment of the VEI, the Volcanic Explosivity Index.
We have a scale for measuring the intensity and magnitude of volcanic eruptions, which is based on several parameters, including the volume ejected and the height of the plume.
The VEI stands for Volcanic Explosivity Index, which is based on a scale of 8.
Based on the volcano's pyroclastic deposits, scientists seek the VEI of Mount Pinatubo. For comparison, the impressive eruption of a Hawaiian volcano in 2018 was evaluated with a VEI between 1 and 2.
When they went to observe the rocks, they saw that they were dealing with a very explosive volcano, with eruptions that are called plinian, that is to say with emissions of large ashes, very strong fallout, and associated pyroclastic flows that went all around the volcano.
We found out that they were thicker than like 2 to 3 meters thick, or even thicker.
When you see the thickness and volume that these deposits can represent, when you are faced with huge deposits that are 100, 200 yards thick, and you are a few miles from the volcano, you say to yourself, well, if it happens, it's something that's hard to really imagine.
It's hard to imagine, unless you refer to the scientists' conclusions. Given its eruptive past, the VEI of Mount Pinatubo is 6.
And at Pinatubo, the eruptions were large, and they were what I think any reasonable person would call catastrophic, if it's something that's going to potentially kill everything from 10 to 20 kilometers out.
And the observations don't end there. The magma chamber is colossal. Beneath the bark of Mount Pinatubo, a lake of molten rock awaits to emerge from the ground.
We can infer that the magma reservoir is between 40 and 90 cubic kilometers of material. It was big, and so this is concerning.
You have to imagine what a cubic mile is. It's a cube with a side of 1 mile. So if a cubic mile falls on Paris, it can spread all over the region.
In living history, no other eruption outside Krakatoa in 1873, whose eruption caused the death of 36,000 people, has been recorded. Unfortunately, Mount Pinatubo's toll could be much higher.
In 91, we had about 30,000 people who actually lived on the slopes of the volcano, in its immediate vicinity, and on the surrounding plains. We had up to more than 500,000 people living under the direct threat of the volcano.
And the threat goes far beyond the archipelago's borders. The eruption of the volcano, through the quantity of ash released into the atmosphere, could darken the skies of the entire planet.
And that could create a real volcanic winter, because all these particles in the upper atmosphere block the sun's rays.
What frightened me at that time is the race against time. That what if it accelerates quickly and we are not able to disseminate this information to these people?
unpredictable volcano. If Mount Pinatubo is suspected to erupt, prediction work must now determine when this eruption will occur. To carry out this mission, scientists use the composition of the air around the volcano. As magma rises, the gases it contains escape through faults in the earth. The closer it gets to the surface, the more the ambient air on the surface is loaded with sulfur dioxide.
Sulfur dioxide is a gas that has a relatively acrid and acidic odor when you are on a volcano, and it is the third most important gas that is emitted by volcanoes after water and carbon dioxide, CO2.
Below 1,000 tons a day, we're equivocal. It might mean that there's not much magma, it might mean that it's just hydrothermal. Sulfur dioxide quantities above about 1,000 tons a day absolutely unequivocally meant that there's magma at depth.
Measurements are taken from a helicopter.
Nous avons utilisé un spectromètre de corrélation que nous avons fixé sur un hélico.
In a helicopter, and we were able to fly to the volcano, and you fly beneath the plume which is being emitted, and you look up through it with the spectrometer. In that manner, you can determine an emission rate of the sulfur dioxide. We measured a few hundred tons of sulfur dioxide that were coming from the volcano. And this increased every time a measurement was made until close to the end of May. We were around 5,000 tons a day of sulfur dioxide.
In general, when there are very big increases like this, that probably means something abnormal is happening in the volcano and the magma is therefore approaching.
The spectrometer measurements form a first beam of indices. A seismograph battery makes it possible to cross-check information. These instruments measure the movements of the ground under the influence of rising magma, and it is approaching.
We are a kind of ultrasound of the volcano. We see the magma that is -6 miles away, -3 miles. It's getting closer.
All the lights are red. There is no longer any doubt about it. The population must be evacuated in view of the upcoming eruption of Mount Pinatubo, unless a strange phenomenon disrupts the rest of the operations. From the beginning, scientists have been planning a large-scale evacuation of the population. Hundreds of thousands of people could be affected.
Our goal at Pinatubo is to save lives.
Among the things that we did was develop the alert levels. At that time, there was no alert level yet for Pinatubo. So we devised an alert level, 1 to 5, 5 being the highest and 1 the lowest.
The plan is as follows. Each alert level corresponds to a zone of 6 miles around the volcano to be evacuated. However, the authorities are faced with an obstacle that goes beyond that of organization: the ignorance or even denial of part of the local population.
Santa Fe, town of San Marcelino, Zambales, more than 1,000 hectares of mixed crops were destroyed.
A star journalist on the largest television channel in the country, Chari Villa, makes the sad observation.
I was just, doing stories of farmers, of residents, how coping with these ash falls, with these little ash falls, and how they're cleaning up their houses every day, and some of them getting tired of it because it keeps, dirtying their houses.
The people are not aware that there is a volcano in their midst, so we had to do double time and also to do extra work to make them, to convince them that there is a volcano, and much less that it will erupt violently.
There is no time to lose. The scientist Maria Bautista sets off to contact the inhabitants and does accelerated educating. With the help of these shocking images, these images of spectacular volcanic explosions were filmed by the French couple Katia and Maurice Kraft.
If you go around the community and start talking about pyroclastic flow layer, they wouldn't really understand what you're talking about. But if you show this video and we tell them this is what's going to happen if it's going to erupt, then we get a more powerful statement.
An awareness that the death of the French couple will sadly reinforce. On June 3rd, not far from the Philippines, in Japan, the eruption of a volcano of the same type as that of Pinatubo created a gigantic pyroclastic flow. 43 people, including the 2 French volcanologists, died.
The fact that they died just then lent even more power and authority to the hazard message in the footage that they took that was in these videos.
But the scientists' efforts are about to be undone by the volcano itself. Earthquakes have been decreasing for several days, and the sulfur dioxide content in the air has fallen. Could magma have stopped its rise? Was it a false alarm?
And so we would fly around in the helicopter when we had a chance and look to see if there were cracks in the ground or steam coming out, and there was nothing happening.
At this time, we were under an incredible amount of stress. Everybody is asking volcanologists for, precise information on when and how big. There were people, outside in the public, in the media, who were saying that the volcano was just some story that was being made up for some political purpose.
Whenever we go to meetings, they are always asking, how sure are you that it's going to erupt? And what if we displace people and it's not going to erupt at all? Then we're wasting, resources, money.
When you've got volcanic activity, you're concerned at first, most of all, the people will be killed before you can get them out of the way. And then you also become concerned that you're going to move people out of the way and then nothing's going to happen. And that has happened several times, and it is a bad outcome.
The dilemma is this: evacuation at the risk of displacing thousands of people for no reason, or doing nothing and leading them to certain death. American experts from the USGS, as well as the French volcanologist Georges Boudin, still remember the tragedy of 1985 in South America.
There was the eruption of Nevada del Ruiz in Colombia in 1985, in which I was present. This eruption occurred on a 4-mile high volcano, which is covered by glaciers. The eruption melted the ice and generated dangerous mud flows. There was a town called Ormero that was completely buried. There were 25,000 deaths, so it was a very big deal.
Volcanologists had drawn up a risk map that showed very clearly that the city could be affected. But in Colombia, the authorities were quite incredulous about the volcanic risks. That's how the disaster happened.
Helpless in the face of the volcano's whims, scientists are unable to know what strategy to adopt. If they want to know more, they have no choice but to take huge risks. June 1991. At the base camp, the scientists' hustle has resumed. The countdown to a major eruption has suddenly begun again.
All of a sudden, the earthquakes, which had all been happening out on the northwest, start happening underneath the summit. And then we see a deformation signal on our close tilt meter.
Magma rises, so the volcano swells slowly about a fraction of an inch to an inch over several miles.
In reality, magma never stopped progressing. It was just harder to locate it with the scientists' sensors.
The magma rises, but it will lose these gases because the conduit is quite permeable. There is a permeability that causes it to lose its gases to the crust, so it arrives at the surface, and it is partially completely degassed.
It looked like we were seeing possibly a tongue of magma make its way toward the surface.
This lava on the surface would be irrefutable proof that the eruption of Pinatubo is imminent. Several helicopter missions are being set up. In one of them, a distinguished guest takes a seat next to the volcanologists.
The general came in and got into the helicopter. And then we flew up with the general. And this is the first time that the general had flown up with us.
Command of those bases is very wary of a group of scientists that they don't know. And they don't know if they can trust us or not. We have to build credibility with them.
The stakes are high. If the lava tongue is visible, the commander will order
donnera l'évacuation.
Let's drop down a bit. Okay, coming down, standard, using throttles.
La manœuvre est dangereuse. À quelques dizaines de mètres seulement du cratère, les hommes risquent leur vie.
Take a look at it from a little bit farther out. I can appreciate your braveness.
Je pense qu'à l'époque, le risque qu'ils ont pris pour Pinatubo, surtout s'ils n'avaient aucune idée de quand ça allait péter, donc forcément, c'était un risque qui était énorme.
Après quelques minutes de vol stationnaire, derrière l'épais nuage de vapeur, au milieu des grandes colonnes de fumée, apparues dès le 2 avril, nous avons vu un dôme de lave.
Le dôme ressemble à une sorte de vieille pâte à pain desséchée, un peu dure.
L'image que je prends généralement en cours, c'est que vous prenez un tube de dentifrice, vous appuyez dessus, et en fait le magma, c'est le dentifrice arrivé en surface, mais il est visqueux, et du coup il ne s'écoule pas et il s'accumule au point de sortie.
Il existe à présent un chemin vers la surface. Le magma sous pression de l'immense chambre magmatique peut à tout moment s'y engouffrer. Le commandant réalise la menace que représente le mont Pinatubo.
That's coming up out of the ground. We got a serious problem.
He can see the growing lava dome. He can see a tremendous amount of ash that's coming out of the ground. He is given to understand that the activity could quickly grow to a magnitude where his base is going to be overrun by pyroclastic flows.
The general turned to his next in command and said, "Do it tomorrow." They evacuated the next morning. That was June 10th.
On June 10th, the scientists issued their alert bulletin.
Are we being evacuated?
The eruption will occur within 24 hours. 15,000 soldiers and their families leave the base in a hurry. The 20-mile risk zone around the volcano pertains to 300,000 people. 300,000 people fleeing the awakening of Mount Pinatubo.
It was just the greatest feeling of relief. But it had other complications, and one of those complications was the sense that, okay, now we've evacuated the people, now what? Is the volcano gonna erupt? How long are we gonna have to watch this? This was only gonna last a limited amount of time, before people started becoming restless and had to go back home.
Wednesday, June 12th, 1991. Today is Independence Day in the Philippines. Today also marks the start of the eruption of Pinatubo.
My colleagues woke me up and eruption already, so they said.
At 8:51 in the morning of June 12th, the volcano let go with a very powerful explosion that sent an umbrella cloud up to, I think, 22, 25 kilometers high.
It had the mushroom shape that you associate with, a nuclear explosion. And then where we were, you could watch the edge of this mushroom come towards us until it was just about straight over the top of us before it started dissipating.
After 40 minutes, strangely enough, the eruption stops.
The people, they were exultant because they thought that everything had worked out great. They'd evacuated all their people, the volcano had erupted, nobody was hurt, nothing was damaged, it's all good.
Drama seems to have been avoided, ostensibly. This first eruption is only a glimpse of the catastrophe that is brewing. The 15-mile-high plumes actually incorporate only a very small part of the magma, that of the lava dome.
It made a kind of plug for the gases that were below, and who have therefore in fact put themselves under overpressure, and that pressure ended up popping.
It actually widens the conduit, and by widening it, it also creates more space available for magma to rise.
The volcano cleared out its throat, it's now open, it can erupt anytime without any precursor.
The magma stored in the reservoir is now free to flow. It's ready to go out.
It's just the sound of the pen scratching on the paper. An eruption signal will just go. And that is one of the most terrifying things you can hear.
Three days later, the much-dreaded eruption occurred. It's precisely 1:40 p.m. when the magma under pressure from the huge magma chamber flows through the conduit.
When magma leaves the chamber and rises to the surface, the pressure drops. The gas that is dissolved in the magma makes gas bubbles in the magma. And as the magma rises, its bubbles are going to get bigger and bigger. It accelerates because when magma rises, it accelerates more and more.
The speed of its ascent is astonishing. The bubbles explode. The magma is as if sprayed.
The volcano opens. There is overpressure, so the column shoots up all at once. It's sort of like a shotgun.
A column of lava, ash, and molten rock rises into the air.
We will have a continuous supply of magma, and therefore it will create a convective column that will rise and continue to rise up to about 25 miles in altitude.
The plumes at one point reach more than 250 miles in width.
The eruption is phenomenal.
things are happening at a scale that you are not exposed to in your typical day-to-day living experience.
While scientists think they are safe from danger, a devastating chain reaction will jeopardize their safety. When the plumes reach the stratosphere, gravity becomes too strong. The outcome?
It will collapse under its own weight.
It's an avalanche that includes gas, blocks, ash, all that stuff inside. It is between 1,000 and 1,500 degrees. It travels at very high speeds, up to 120 miles per hour.
The speed of this pyroclastic flow is explained by its gas content. The latter plays the role of air cushions, facilitating the progression of volcanic debris.
The trajectory of pyroclastic flow is normally determined by gravitational forces and the local topography. So they can change, they can actually jump over ridges.
And as if that were not enough, adverse weather conditions add to the disaster. A tropical storm with heavy rain and winds at 120 miles per hour is heading straight for the erupting volcano.
In these regions, there are monsoons, rainy seasons, typhoons, hurricanes, cyclones.
If someone had told me I was going to attend one of the biggest eruptions in the past 100 years, and at the same exact moment there would be a typhoon, I would say no. That's a stupid Hollywood scenario.
Typhoon Yunya was coming in. So that was the last we saw of the volcano, was pyroclastic flows going out 10 kilometers on one side. We're 20 kilometers out the other side, which is not much of a margin of error.
And all of a sudden, the situation escalates.
We didn't have any satellite information from where we were. And we were seeing our equipment fail one by one. So it started with the one nearest the crater.
And I looked at the screen, at the computer screen of our seismic data, and I noticed that there was no data coming in from any of the stations. We would know where these pyroclastic flows were coming down.
We went right out of the base ops, and right away the pumice, the rocks like this big, were raining down on us, okay, on our head, like, and it's popping on our head.
The size of the pumice that was falling at the base was becoming larger. It went from 1 or 2 centimeters to 4 to 6 to maybe 6 to 10 centimeters in diameter. It was time to leave.
The scientists leave the military base in a hurry in the slightest hope of outrunning the monster.
Looking over our shoulders to see if there's a pyroclastic flow that's going to overtake us. So, yeah, we're afraid, and you'd be a fool not to be.
That was the most terrifying moment of my life.
A few miles away, journalists are also fighting for survival. Pyroclastic flows pursue them.
You can imagine in a rough road, the car was doing like this, and the speed probably 80, 90, or 100. Because we were telling the drivers, go, 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 we will die here. Mas matuloy tayo dyan!
Against all odds, the typhoon will help reporters get out of this hell.
There was a huge wind, we would say. I feel the wind was a very strong wind, and the pyroclastic window, and we all reclaimed. And then they said, oh, thank God.
But journalists and volcanologists are not out of trouble yet. Mount Pinatubo leaves no respite. 2 hours after the first explosions, the eruption took an apocalyptic turn. The volcanic ash mixes with the clouds and the rains of the typhoon. Day becomes night.
Believe it or not, right now it's not even 4 o'clock in the afternoon. It's a little bit larger than ash is what's falling right now from Mount Pinatubo.
It's so dark. And I said, maybe this is the end of the world.
And suddenly there was like ash falling. Like our windshields you cannot see anymore.
As there was a typhoon at the same time, the ashes are actually loaded with water. They have become much denser.
See anything, it was raining ash. The problem was the windshield of our car. You have to wipe it up. It so happened that we had cherry coke, sorry for the advertisement. Use all of this to clean up our windshield along the way.
Danger doesn't just fall from the sky. The rivers, which are also full of ash, come out of their beds. They form what scientists call lahars.
The lahar can advance at 10 to 40 miles per hour. It can be as hot as 140 degrees. Sometimes it can travel tens of miles, or even 100.
It's going to be like a river of cement or concrete, and that's as devastating as possible.
Usually, lahars happen like days after, but this one right after, because there was typhoon, there was rain, right away there was lahar.
And we can hear the lahars coming down the drainages, kind of an indistinct roar in the background.
Along the way, there were a lot of people asking for our help to be in the car. And we would say, we cannot accommodate you because you're already full, and also it's very hard.
They were crying. They said, this is the end of the world. Repent, repent. There was shiver down my spine.
After 9 hours of continuous eruption, Mount Pinatubo is showing signs of shortness of breath. Emptied of 10% of its contents, the magma chamber drops in pressure.
You reduced overpressure, and then the volcanic top is no longer supported by the pressure of magma. It just simply collapses into the empty place, creating a caldera.
The volcano is blown away, it is decapitated, it is cut off. It loses over 300 yards in altitude all at once.
The collapse of the summit foresees the end of one of the worst eruptions in history. Until 3 months ago, Mount Pinatubo was completely unknown. Here it is at the center of attention, considered by scientists to be a killer volcano.
And thousands of Filipinos fled to safe ground after explosions from the Mount Pinatubo volcano spewed ash and rocks.
It was monochromatic. Everything was gray. There were no colors. Everything was covered with ash.
You see, oh my God, this is like a black and white movie.
It was complete destruction. In places, the pyroclastic flow deposits were 200 meters thick. A sense of lifelessness.
The eruption wiped out all life within a 12-mile radius. There were 350 victims, most of whom died under the collapse of roofs weighed down by ash. In addition to the immediate consequences, additional ones will be added. In the following years, monsoons will awaken new volcanic sludge in the region. In total, the awakening of Mount Pinatubo caused the disappearance of 800 people in the region. The phenomenon will even have a global impact. Ilya Bindman is a volcanologist specializing in climate eruption interactions. He claims the astronomical quantity of volcanic ash sent 40 kilometers above sea level threatened the Earth with a volcanic winter.
For example, after the eruption of Mount Pinatubo, something like 20 million tons of sulfur dioxide was delivered to the stratosphere. This sulfur dioxide got oxidized into sulfuric acid, and that created aerosols which blocked sun rays from reaching the surface. And that created the climate pool.
The eruption of Pinatubo caused lowering of temperature of the Earth because the ash was able to circle it twice.
The cooling was estimated at 0.5 degrees.
The aerosol layer was even observed from space. It's the black band visible on this picture taken by an American space shuttle a few weeks after the eruption of the volcano. It took 3 years for it to wear off. Because of its magnitude, the eruption of Mount Pinatubo changed the history of mankind. Through their work, scientists changed the history of volcanology.
It was only a few weeks, but it's indelibly printed on me intellectually and emotionally.
Mount Pinatubo taught me and helped me to be more in tune with nature, to be more respectful of it.
Today, Mount Pinatubo is asleep again. However, it remains in the sights of the scientists who monitor it. Behind its blissful appearance, it can take all forecasts by surprise, just as it has done in the past.